Let's look at IP tables in this section. This is the IP version 4 user space utility, which allows us to manipulate the firewall. So it features IPv4 firewall user space tool, which allows us to write rules based on protocols such as TCP, UDP, ICMP, etc., with most applications being bound to TCP. But of course, there are your common UDP applications like DNS, DHCP, SNMP, etc. So IP tables is a user space tool. That means it's available to us as administrators, but it really communicates with the net filter core of the Linux kernel. So it sends and receives instructions to and from the kernel via user space. So normally when you use IP tables, you manipulate layers 3 and 4 of the OSI model. So typically manipulates layers 3 and 4 of the OSI model. So you're generally writing rules restricting traffic based on IP source and destination, or TCP, UDP, and so on. So layer 3 involves the routing protocol. So routing, which in our case is IP or IPv6, which entails source and or destination filtration or filtering. And at layer 4 of the OSI model, we're concerned with transport. So for example, TCP or UDP, or let's say ICMP, and so on. So at layer 4, we restrict traffic to and from based on source or destination ports. So source and or destination port filtering. So this is how you typically use IP tables, whether within the IPv4 or IPv6 spaces, to filter traffic at these layers of the OSI model. So let's set up some tasks. One is to explore the current configuration. During installation, we elected to have the firewall enabled, which is the default. We disabled it eventually so that our connections would not be filtered. So currently, the firewall is operating without any rules. Now let's take a look at the shell. We'll RPM query all, grep case insensitive search for IP tables, and it returns the packages that correspond to v4 and v6 respectively. The first package relates to IP version 4, so let's query list it. And these are various modules that handle different packet filtering functionality. So as we scroll towards the top, we see an IP tables XML binary, IP tables init script, a config file in etc sysconfig, which determines options that apply when IP tables is launched. As mentioned, a number of modules to handle the different types of packet manipulation. For example, redirects, masquerading, which can translate as network address translation does. They're one and the same. Source NAT. There's also one for destination NAT. Logging, ICMP. All of the properties of TCP/IP, in this particular case version 4 of IP, are broken out into distinct modules which can be referenced, and they're loaded as necessary by IP tables. The main tool that's used to manage IP tables is called IP tables. It's accessible to the root user. And there are some ancillary tools like restore and save, for example, which allow us to restore and back up the configuration. So let's just note key binary for managing firewall rules. But then there are also the restore and save utilities, which are important, which ensures that the system can recover with the rules that have been defined and allow you to back them up. So restores rules after reboot and or a flush. Let's say you flushed the firewall table while the system's up, but determine at some point you need to restore those rules without rebooting the system. Then you can use iptables restore and point it to the file that contains the rules. And then there's a save utility which archives current rule set and counters, packet counters. So you save your rules with save, you restore with restore, you manipulate the firewall with iptables. These are the key binaries that are included. As mentioned, it runs as an init script. It's also loaded by the kernel, so if you lsmod, for example, and you grep out iptables, you'll see the modules that the kernel has loaded. So for IP6, it's loaded tables and table filter, and for 4, the counterparts. So it's dynamically loaded. Now let's look at our current configuration. To do so, we just use iptables, which is in our path as a root user. So iptables list is our first option. So this enumerates the default table, which happens to be called the filter table. There are a number of tables managed by iptables, and this will load for us the filter table, which is the default. So when we execute it, it lists that table, and in each table there are various chains. Chains are basically lists of rules. So for example, the input chain governs traffic that flows inbound towards the system, regardless of interface. So if you have 2 interfaces, inbound to either of those interfaces. There's a forward chain which governs traffic that flows through the host with respect to routing. So in one interface, out the other. And then there's the output chain which governs traffic sourced by this host outbound to somewhere else. And that somewhere else could be itself, or some other host on the local subnet, or some other host on some other subnet. So within the default filter table, there are 3 perspectives to keep in mind. Let's just note them. And they're called chains: input, forward, and output. So let's just note iptables maintains a number of tables, including filter, which is the default, nat, mangle. However, the filter table is where we spend our time because it governs traffic in, out, and through the computer. So within the filter table there are a number of chains. And let's just note as well that each table maintains a number of chains, which leads us to exactly what a chain is. A chain is simply a list of firewall or filtration rules. And chains can point to additional chains so you can string them together. So from the perspective of the filter chain, we have, or filter table, we have a number of chains, including the input chain. And the input chain is concerned with traffic destined to one of the interfaces governed by the host. So regardless of where it comes from. So if we take a look at ifconfig, for example, we have ETH0, ETH:1 and 2, those are just subinterfaces, and the loopback interface. Any traffic that's destined for either the loopback or ETH0 or even the aliased interfaces which have distinct IP addresses would be considered input traffic, so long as the source is exogenous, meaning it comes from the outside. Meaning, if you source the traffic from some other interface on another host destined to the input port of one of the interfaces governed by this host, then that traffic will traverse the input chain. So it's traffic sourced by an outsider destined to one of the interfaces managed by your system. So traffic destined to one of the interfaces governed by the host and sourced by an external host or party. That's the role of the input filter. So that's where you write rules that govern traffic coming from somewhere else into your system. In between input and output, there is the forward chain. This is for traffic destined to be routed through the host. That means traffic has entered one of our interfaces and intends to leave another interface. So think routing. And then there's the output chain. And this is traffic sourced by our host destined to a remote host. So to restrict the traffic that may leave your system, write the rules in the output chain. For example, supposing your corporate policy states that no outbound traffic to TCP 25 should be allowed, which is sensible, which many ISPs restrict, then you'd write a rule in the output chain, akin to, let's say, a Cisco firewall's output chain. The perspectives are virtually identical. From the perspective of a router, anything inbound is entering one of the interfaces of the router. Outbound is leaving one of the interfaces, and otherwise it's routed through, which the router does inherently. So it's implicit, doesn't need to be stated. So how do we impact the rules that are in these particular tables? Well, we need to write them using the syntax that is supported. So we can list using iptables list, but to add we can use a number of options, including insert and append. So let's list as a second task, write input chain rules to filter traffic and test. So we have to come up with some scenarios that are of interest that we may want to restrict. So let's see which ports we're listening to, services that others remotely may be interested in. So netstat.ntl shows us TCP listeners, for example, although you can write UDP rules, but TCP tends to be the easiest to test using Telnet, for example. So netstat.ntl shows that we're listening to perhaps too many ports. 2049, NFS,